We're now going to transition from the workplace to capital investment. Leaders from venture, private equity, and impact investing will explore how private capital can accelerate brain innovation while achieving strong financial returns. With compelling evidence, high growth potential, and significant social impact on the horizon, will investors seize the opportunities? For this discussion, please welcome to the stage first our moderator, Dan Mannix, advisor to Brain Capital Alliance, founder of Nixum Synergy, and former CEO of RWC Partners. Next, Eric Bennett, founder and managing partner with Brain Capital Partners. Now, Dr. Amy Cruz, general partner with Satori Neuro. And Dr. Jacob Robinson, professor at Rice University, CEO of Motive Neurotech.
It's great to be back in Houston. I first came here about 2.5 years ago to a Brain Capital conference at the Baker Institute. It's been an incredible journey to be part of, and today is testament to the progress that we're making, the commitment of Harris and his partners, and the unique power of Brain Capital to convene stakeholders across different sectors to think about the health of the brain and how we can make progress towards greater health and productivity. As someone from the UK, it's really energizing to be in a city that's so proud of its innovations and successes. And I think it seems to me that there is a pivotal moment where Houston can use this conference as a launchpad to lead the world in neuroscience in creating an impact, action-orientated, optimistic, and aspirational mission on the health of the brain. I spent 25 years in asset management building a business that worked with major institutional clients around the world, including a number of important health foundations that are located close to us today. But I'm here today because my passion and ambition is to harness the collective power of the people in this room to improve the outlook for our nation's companies, families, and individuals in relation to their health and productivity. I believe that the stars are aligning. There's a moment in time where scientific and technological innovation is providing an understanding that we've not previously had. And from that platform comes a world of opportunity for the creation of a rapidly growing industry that operates at the nexus of science, health, technology, and human productivity. But we must remember that we're only in the foothills of the transformative period, and I'm delighted to welcome three friends and leaders for a discussion about how we connect the impact that can be had from innovation to the critical requirement for investment and returns. So I'd like to start by introducing Jacob Robinson. He'll be well known to many of you. He's a distinguished professor at Rice University and one of Texas' most respected neurotech entrepreneurs. He's raised over $25 million since 2022 for his neurodevice company called Motive Neurotech. Amy Cruz is a neuroscientist who's worked across research and industry and spent a number of years at DARPA as a program manager. She now leads Satori Neuro, one of the first venture capital funds dedicated entirely to mental and brain health. Eric Bennett spent 25 years building Tolleson Wealth Management, where he invested for clients and families shaping their long-term financial strategy. He spent 4 years as executive director at the Center for Brain Health and has since invested over $400 million in biotech investments. That makes him one of the leading experts in brain-related allocations to venture capital funds. And recently he's seen the opportunity to launch a new business dedicated to investing in the space. Hi.
Hey, Dan.
Hi there.
Well, thank you all for joining me. It's great to be hosting this panel. Jacob, I'm going to start with you. Clearly, you are at the absolute cutting edge of technological innovation in relation to thinking about brain health. Maybe you could touch a little bit on what you do. But I think something that I'm fascinated by is what actually are the technological changes over the last 10, 15 years that have enabled you to do what you do today that simply was out of reach prior to that?
Yeah. So briefly about what we're working on at Motif is the idea that for decades, we've been trying to treat mental health disorders with pharmaceuticals and talk therapy. And we've recently learned that there's a lot about what's happening in the brain that can be understood as patterns of brain activity that look a lot like electrical circuits. And that has led to the idea of using devices to help treat disorders, particularly when those disorders are not well treated by drugs. And we know that they currently aren't. About a third of people fail to respond to 2 or more antidepressants. If you do respond, the side effects are often too difficult to stay on those types of therapies. And so we founded the company with the idea that there's going to be a period where we turn to devices as interventions for things like mental health. We've already done this in the cardiac space, right? There was a period of time before pacemakers where the only thing we had were drugs. And then we figured out that we could use devices and help save people's lives. And now it becomes second nature for us to combine drugs and devices because these are life-saving therapies. Suicide is the #2 leading cause of death for ages 18 to 35. If we could do a better job of suicide prevention with a combination of drugs and devices, we'd be saving lives just like we do with cardiac pacemakers. So we started Motif with the idea that we can create those types of interventions by taking devices that could be miniaturized to about the size of a pea and implanted in a 20-minute outpatient procedure. And there are other companies in this space. I mean, I think we're the best one. But this is part of a sea change in the way that we think about treating mental health. And I think, there are a lot of technical innovations that have made this time particularly special for the types of companies like mine that are coming out. And this is something that I hope to communicate here to you guys. And we were talking about this in the back that, I came from academia where I spent a decade running a research group in electrical engineering, and I saw the foundation of what could be a technological revolution in neurotech. And that is informed by the idea that we can now build devices that are extremely small, very powerful, with very high data communication rates in ways that were never possible until now. And what it looks like actually is an exponential growth in technological capabilities. So I apologize, you can tell I'm a professor because I'm like, Nema, let me tell you about Moore's Law. But I'm going to tell you about Moore's Law. So what this looked like when I was looking at the data is that there's this exponential growth in the amount of data that we can pass into and out of the brain. That exponential growth curve looks an awful lot like the exponential growth of semiconductor technology back in the 1980s. In the 1980s, there was this idea that you can pack more transistors onto a silicon chip, and that would lead to 2 really important changes. The first important change was that there's going to be exponential growth in performance. So computers in 1980 were going to get exponentially more capable. The other thing is that the costs were going to come down exponentially as well. Now, those 2 things made people realize that although in 1980, not a lot of people had computers, that was going to change. And so there's this company called Microsoft, and their big idea was everybody's going to have a computer. And people thought that was wild. And here we are today where we have many of these devices. And it seems really weird to think, it's almost hard to think back to the idea that we wouldn't have a computer device. But that's what happens with exponential growth. It radically changes society, and it radically changes what we believe is possible. And there's this exponential growth both in the technology that's allowing us to intervene with brain activity. And there's a second exponential growth, which is often underappreciated, is there's exponential growth in the science that helps us understand how we can use that. And if you look at the number of clinical trials as a function of time, that's growing at an exponential rate that's even faster than the technology. So there's been this incredible investment from the government through things like the Brain Initiative, DARPA, Amy was part of a lot of that work, that has now given us not just the tools to make these interventions, but the understanding of the brain to make the most utility of those tools. And so when I look at it, I'm like, this is the 1980s equivalent of the semiconductor industry for neurotech. And so we have the opportunity now to build that future where it's going to be second nature. In fact, I would argue there's going to be a time not too long from now when we can't imagine our lives without the ability to use devices to help us perform better, to overcome mental illness, and just to be our best selves.
And I think, would it be fair to say that the miniaturization of physical devices enables us to capture data? But an additional one of the stars that's aligning is our ability to collate huge amounts of data in an automated and intelligent fashion. So do you see that as another critical star aligning? Because if you could miniaturize something without being able to process the data, would it be useful?
Yeah, that's a great point. I think it would be useful. So I think about it as, like, you know, coming back to the pacemaker analogy, if we had really tiny pacemakers without the ability to use data, we could still like treat heart disease. And I think we could do the same thing here. I think in the absence of using any of the data, we could still treat mental health disorders better than we can with existing pharmaceutical interventions. But we can use the data. And I think when we use the data, it's going to unlock additional potential, which is the ability to personalize the therapy. Like right now, if you go to your psychiatrist, they're going to give you like 40 milligrams of whatever. It's the same thing they give to everybody. But with an electronic device, they can tune it to each person. So I think it'll start with this like lack of personalization. We're all going to get the same kind of device intervention. But because we have access to the data, it's going to be tuned to our own individual needs. And I think that this is a really exciting space because right now we're operating in this industry of psychiatric care without quantitative measures of your performance and your outcomes. So when you go to your doctor, they're like, how are you feeling? Is it better than you felt like 4 weeks ago? And I'm like, I can't remember. Like maybe you don't do this with your, you know, if you're managing diabetes, right? They like look at your blood sugar. You don't do this if you're managing cardiac health because they have quantitative data. What's going to change is that we're going to have quantitative data to measure mental performance. And that, I think, is going to be an even greater revolution on our ability to improve because we can actually measure it. And once you can measure, you can improve.
Yes. And I think that's a critical thing that I feel we need to demonstrate to investors and clinicians is that efficacy is higher, and that requires personalization.
Yeah.
So, Amy, you've had a distinguished career as starting as a neuroscientist, but also working within DARPA and industry. I mean, clearly DARPA has experience of large amounts of capital devoted to solving particular problems. Do you see any analogies with neuroscience and the treatments and innovations that you're seeing coming to market that can be made with that industry? And do you think it's realistic to say that it is actually different this time? We can be more optimistic about improving outcomes for people.
Absolutely, and I think part of that is, and this is, you know, kind of building off what Jacob has shared around the miniaturization, data, and other things. I understand, you know, for a lot of people, the brain still feels like a mystery, and yet so much science has been accomplished that we can now operationalize and move into engineering, right? And so I think that's one of the places where, you know, it maybe seems like these things are quite distant, but we know a lot about the brain at this point, right? And we know about these networks that are, you know, overactive in anxiety and underactive in depression, and OCD looks different than another condition, and those are quite actionable. And so I think the why now for me is the miniaturization that we've been talking about, right? This network understanding of the brain that we've been talking about, and our fundamental understanding, which we've been hearing about over the last 2 days around neuroplasticity, the ability of the brain to be changed, to change itself. And so I see us as moving into this very solution-oriented space, which is the perfect point and the perfect intersection point for investment, the type of, industrialization, creation of products, creation of new medical products, creation of systems that people can invest in. And so I think that, while there is still this perception that the brain is complicated and there's still things we don't understand, the things that we have been talking about over the last 2 days, we have a good grasp on, and it is that quantitative element that is making it, something that I think personally is investable. I do think that we are, again, in the context of the things that we've been talking about today, I do think that we are still seeing the majority of the investment come into the clinical space, right? Like we know that there is human performance optimization. We know that there's, workplace. There are many things that we can work on, but I think this first wave is really taking advantage of the science that's come from NIH and NSF and the Brain Initiative and DARPA's investments and hopefully now ARPA-H investments, right? And really pulling those things forward. I think clinical will still be the first things that we will see sort of operationalized and engineeringed, right? But after that, I think we'll see a wave as more individuals have devices or interact with neurotechnology in that way.
And I mean, this discussion is focused on thinking about the availability of capital for the development of new ideas, and we've heard a lot about the need to think strategically about what should that capital be allocated to, essentially, i.e. how can we actually invest money strategically to improve the outcomes for society and organizations? And on the basis that we are actually passing through a moment of technological transformation which makes the outlook very different, I'd like to introduce and ask Eric. I mean, you've been investing in venture capital funds now for well over 2 decades, and what do you think the critical factors are that are going to change neuroscience from being something that has been heavily invested in people who are passionate about possibly mental illness, maybe because they have a family member who's suffered and they want to do something to change it, or because perhaps they're researching a particular modality that's interesting. But what changes that to make this a viable investment within more mainstream portfolios? Because my experience of investment management tells me that we need to reach that tipping point in order to see capital flows come in the scale that we need to actually crystallize the opportunities available.
Well, first of all, good morning, everyone. Thanks for being here. It starts with the science, right? The world you see is like, my perspective is more as an investor, and so I've been very active in following the brain space for the past 12 years. And I would honestly say until 3 years ago, from a venture perspective, most people would view it as uninvestable. You've had such little progress in the brain from a science perspective for a long time, right? Prozac approved in 1987, not much for mental health since then until recently. And so I looked at it and said, I invested broad in biotech, but I don't want to focus on neuro until I see signs that other investors in the space. I can't just be alone on an island, right? And I saw, so for an example, it would be, Jacob, your company, one of your investors is a Austin-based venture capital biotech fund. And I know the guy really well, and I invested in his fund, Broad Biotech, 8 years ago. And he's like, Eric, I just don't ever see myself doing neuro, so don't send me neuro deals. Now he's got a neurologist, neuroscientist working for him, and he invested in Jacob's company, which is a long-term investment, right? So this is the same guy that said 7 years ago, thanks, Eric, but no thanks. Neuro's too risky. But I'm seeing that broaden massively. And I think that the people called it like the uninvestable space to the next frontiers. And so I look at things like, okay, who's going to invest in the space, right? You have venture funds, you have biotech hedge funds, you have big pharma, you have private equity funds. So who are the providers of capital for profit that were largely absent from neuro even 3 years ago have leapfrogged into being a big part of their theme, right? So, Johnson & Johnson's famous for Eli Lilly, like we're out of neuro, we're in neuro, we're out of neuro. Well, they just made a big acquisition in neuro. So I had to see the ecosystem develop for investing because, grants from the government, private philanthropy can take it so far, but if it's a research paper and it just sits there, who's going to bring it out? And I've just seen that ecosystem develop a lot. And there's someone from JAMA here. I don't know if she's here. I saw her in the hotel lobby, but I'm going to steal a chart if you want to throw it up. Don't worry about the numbers. Just look at the visual. You can see like a year after COVID. In the investment world, we call this kind of a hockey stick shape, which is what you want to see, which is things start to create exponential growth. And you can see for a long time, you're close to zero. This is funding and venture capital for neuro. Like, look how, close to zero for a long, long time. And after COVID, it started to go up. And so I'm seeing that real time with venture funds, with biotech hedge funds, with big pharma. And that's what's got me excited and caused me to launch my firm to focus on neuro investing, so I can invest with Amy and I can invest with Jacob, because there are just a lot of great things going on right now that were not there 3 years ago.
Yeah, and just to add on that, I think you're bringing up a really important point, which is it really is a momentum game, right? For a long time, the big pharma companies were out of psychiatry, and then all of a sudden, now they're back into psychiatry, right? And you're seeing multi-billion-dollar deals get done. When bean counters can put those sort of outcomes into their spreadsheet, and even with their, discounted cash flow, get a good number out of that. Like, people get excited, and that builds, and then the companies themselves build, towards new deals and say, hey, we want to be leaders in this space. When you start to hear companies say, we want to be leaders in CNS, central nervous system space, that's a good sign. Also, as we were chatting about, there's a big report that came out of Morgan Stanley around the brain-computer interface space, sort of drawing at least an initial addressable market of like $450 billion around that space. That includes companies like Motif, Paradromics, another Austin-based Texas neurotech company, right? You start to see those types of numbers, and people, again, start to put those into their spreadsheets and get excited about that. We're really at that growth phase. And so I think the question is, how much capital, can we draw into this space? And this conversation that we're having is a big part of that conversation.
And Amy, when you try to think about the alignment between a lot of what we've talked about here, which is actually the impact on humanity, society, corporates, does that align with the commercial opportunity that you invest in, or do you get the commercial opportunities not necessarily matching with the societal objective? Yeah,
so that's a really interesting question. I think I'll go back to the initial point that I said. I think the large amounts of capital are definitely going into the clinical space. I think that's the initial outcomes that we're seeing, because that's the size of the deals, outcome deals that are getting done and things like that. The other half of my portfolio is actually on what I would call infrastructure, access to care. How will people, get access to these amazing treatments and other things? So I think we are seeing movement in the employer the EAP space and the workplace capital space, but it's been subclinical, right? So I think those two things are a little bit separated right now in terms of what people are looking to support. I have a company in my portfolio called TaraMind that's working on novel insurance benefit for treatment-resistant depression, giving people access to IV ketamine, which right now is not covered by insurance because it's used off-label. That's an example of where, we're trying to bridge that gap between, what people might have experienced for cash pay, like what is efficacious but would be out of pocket, and trying to create an employer-sponsored benefit for a thing like that. There are a couple other things in my portfolio that are like that. And so I do think we're seeing movement there. We took a little bit of a hit because of GLP-1s. So that kind of shot to the top of employers' concern, list of things that their employees wanted access to, but mental health is always in the top 3.
Yeah, and I think this is something that we, as the brain capital community, have studied at length and will continue to work on, is that where there are those pockets of societal need that are not necessarily going to be met by market forces, that's where you need to engage the public-private partnerships to have the government intervene and essentially provide some kind of tax incentives to alter the risk-return profile to focus investors' minds back on the areas that are make the biggest differences. And there is a great analogy there to do with the commitment to alternative energy sources, where, as someone from the UK, our government made a decision, wrongly or rightly, that we would move to a very alternative energy grid. And they provided enormous tax incentives, and so consequently we have these enormous windfalls all over our beautiful countryside. But it does work when there is strategic understanding of what matters. Jacob, we had a fascinating conversation yesterday about essentially the buyers are critical to the investment. Without line of sight to adoption of new technologies like yours, the capital's not going to arrive. It clearly is for you, and that's extremely encouraging. But would you say that the community is yet ready to apply technological advances in relation to the brain? And I think we talked at some length about the heart, which I'd be fascinated for you to repeat some of that discussion.
Yeah, I think there were a couple of things that I struggled when I was fundraising with, because I naively went into this space because I saw the data and I was like, wow, this is the right opportunity. We know how to intervene for these conditions. We have technology that we never had before. Like, of course this should work. And then I went to try to raise money, and people were like, how do you measure depression? What's your endpoint? Is it subjective? And I'm like, well, it's the same surveys we use when we approve antidepressant medication. But right now we're struggling against these kind of soft endpoints in this space because we don't have great ways to measure it. And this was different than cardiac care, where you could measure very quantitative physiological markers of cardiac health. And we're in this weird point where we don't yet have devices like mine deployed at scale, where we can collect the data to then give us the quantitative measures to have more endpoints that look a lot like cardiac health. And so I needed people to take a little bit of a leap of faith that we're going to get there. And we're at a point now where there's enough that we use from the pharmaceutical industry that we can apply to devices, and it's only going to get better. And so that's an area where I feel like there's going to be a huge unlock. Is once we start to measure mental health with the same precision that we do cardiac health or oncology, that's going to unlock a lot more. But that was really hard for us. And the second thing that was really hard for us was this idea of adoption. They're like, who's going to put a device in their head? And honestly, when I was starting, I also had a hard time with that. And I'm taking a big risk, right? I'm a tenured professor, going to start a company and totally upend my life for this thing that I don't know if people are going to want it. And in fact, my wife was like, really? Are you sure about this? And I started to think about what was it like when people proposed a pacemaker? I'm going to stick wires in your heart. It'll be fine, And this is an organ where a little bit of damage is a huge deal. In fact, your brain is much more resilient than your heart, but we haven't yet crossed that threshold where the idea of a device to help heal the very organ that's causing our disease, why wouldn't we do this? Particularly if it's far safer than a cardiac implant. And I don't think we've reached that point as a society where there's enough of these things out there in the world, and you know an aunt or an uncle or a cousin or a sister whose life was saved because they got a device. That's when I think we start to see change in mindset. But until we get there, we have to take this leap of faith. And that's been a real struggle for companies like mine, and I'm happy to see things changing. Like KDT, we were the first neurodevice investment. So we're seeing investment from pharmaceutical companies who are beginning to see this as a disruptive technology for them. We just closed with a major US pharmaceutical who's getting back into the central nervous system space, and they were here for my board meeting, and I was like, dude, you guys develop drugs. Like, why are you talking about, coming here for devices? And what they're looking at is the fact that this represents a disruptive technology for the pharmaceutical industry, and they want to know what's happening because they see this as something that could totally change what's happening in the central nervous system. And in fact, the analogy that he made to me was oncology, where for the last 20 years, a lot of the pharmaceutical companies were making their money in oncology. And it was because they were like, cancer is really like a lot of different disorders. And so there's like a lot of different treatments. No one is like, here's your cancer drug for all cancers, right? It's like you have small cell, whatever. And they see this happening now in the mental health space, where like depression is actually many different disorders and need different types of therapies and interventions. And so I think they're beginning to see the opportunity here that there could be a revolution in mental health in the same way there was in oncology. But it still takes a little bit of a leap of faith for both quantitative outcomes and the belief that there's going to be adoption for devices.
Yeah, I was just going to add to that around the quantitative piece, particularly as it relates to precision psychiatry. I think a couple interesting things are happening there. First of all, you see the pharmaceutical companies are the ones that are getting most engaged around precision psychiatry because the reason, and this is going to be terribly shocking to you, I know, that brains are different from one another, right? And so a molecule might have failed in the past because it was tested on a very heterogeneous group of individuals that didn't even have the underlying condition that it was being tested on. And so now pharmaceutical industry is really interested in precision psychiatry because they realize that, we can start to design better clinical trials, and that means our drugs will be more successful. And so you see this new wave of what's happening in the pharmaceutical industry. Obviously, those timescales can take quite some time to develop, but there's companies like Alto Neuroscience, right, that are going back and rescuing old drugs that probably will be successful on the appropriately selected positions. I wanted to anchor this back around precision psychiatry to the, again, larger conversation that we've been having around stigma. I do think there's a value in having quantitative measures for some of these brain disorders that gives people the sense that it is something that can be solved. This is not a personal failing, right? It's interesting to see the way that GLP-1s have changed the conversation around weight loss, right? And all of a sudden it's like, wait, maybe it's a brain metabolic disorder, and maybe we're getting into that space now with some of these things. And I do think, we're having this conversation around brain health. Don't call it brain health. Don't call it, call it this, don't call it that, right? And I do think that adding quantitative metrics to these things will help liberate them from being perhaps stigma or personal failings, and maybe move us into a space where it's more like cardiac and it's more like other things. So I don't know, just to add that.
Yeah, I mean, Eric, it's always been fascinating to me. I come from a side of the investment industry which is very much about cash flow and valuation. Clearly, in cutting edge themes and sectors like we're talking about here, you don't have cash flow yet. So is from your perspective, having looked at different sectors in venture, do you think the neurotech area is going to start providing the data that evidences the things that investors need to see in order to allocate capital?
Yeah, I think neurotech's just one area. I mean, it's because of the blood-brain barrier, drug development's more difficult, and from going from mice model to humans is very difficult. So the whole neurotech market, to me, is very exciting. It's like a new modality created largely around the brain, right? So, and thank you to Elon Musk, whether you like him or not, for creating Neuralink, because like I haven't met anyone that doesn't know who Neuralink, including my mom. you know. I think it's very exciting what's happening in the neurotech space, and you know, AI and technological developments are gonna speed that up. But it's not the only area, right? It's just an emerging area that was. I mean, Jacob, you've been working on yours for how many years have you been in the lab?
Oh gosh, 12.
Yeah, 12 years, right? So, but you know, it's been the past 2 or 3 years that you've had, you know, investor capital.
That's right.
But it's interesting in that it's, you know, I've been an investor in like almost every asset class possible, from bonds to emerging markets with Dan's old firm to equities, you know, private equity, venture, biotech. But in biotech, most businesses, you need to create some sort of revenue stream or cash flow to become more profitable. In life sciences, you just need the science to advance. So, for example, there's a nasal spray company that's got a nasal spray compound for concussions, and all their work's in lab mice. And according to my concussion expert, that is very compelling. But he's got to go to clinical trials, right? So let's just say it's worth 10 million today. If he has a successful clinical trial, that company could be worth 5, 10x immediately with zero revenues, just because the science has been de-risked, so more people are interested in it, to becoming the standard of care potentially for concussions. So that's just one example of, you know, we can make money as investors, Amy and I, just if the science is successful in clinical trials. And then someone else comes along, if big pharma comes along and says, well, we know that they're generally not very good at innovation and creating. I don't know, someone told me about how, you know, like less than 1% of the new drug development comes from big pharma. I forgot who told me that. But most of it's coming from the universities and then venture capital and then on. That's what's exciting about it, is that, you know, I'm like a cash flow guy most of my career. This is not a cash flow investment. You know, I want to be long out of it by the time there's cash flow. I want big pharma to own it and have our exit.
Yeah, I mean, one of the things that I'm advocating for is the U.S., Texas, Houston in particular, have a moment in time where there is an opportunity to become a center of excellence globally for neuroscientific development. And I can tell you that as someone who comes from the UK and Europe, the US is a unique operating system because the availability of capital aligns with scientific endeavor and attitude to risk and a very large population that can be addressed. And that doesn't exist elsewhere in the world. Let's hope that the uncertainty over funding levels is relatively short-lived in the US, and let's hope that other large populations in other geographic areas pick up some of the running as well. But I think short-term that does create a fantastic opportunity to build not only an industry, but a center of excellence. And I think that we mustn't underestimate the importance of capital. And capital tends to come in the early days from people you have close proximity to. And so just coming to you, Jake, but I imagine one of the less natural parts of your job is the requirement to raise capital. You've clearly done a great job, which I think is a reflection of having a great product and doing a great job with investors.
And they like me.
Yeah, and you, of course. But the question I have is that when you're out there searching for capital locally and around the US and potentially internationally, where do you see the capital coming from, and what would you like to see other than much more money?
More. Like the
But
answer's more.
what are the trends, and what would you like people to understand about the capital raising environment and the opportunities it creates or restricts?
Yeah, so we actually drew capital from a lot of different places. It was fortunate in a weird way that I founded the company right around COVID. And at that point, there was a shift where in-person investor meetings were not considered as mandatory as it had been in the past. And that allowed me to hop on Zoom and raise money from Silicon Valley a lot more easily, even though I founded the company here in Houston. And so I think there's going to be a little bit of, I've seen some relaxation over where companies get formed. You don't have, like, I didn't have to start in the Bay Area. And that was because of the ability now with Zoom, people had to meet remotely. And what I noticed was a little bit of a shift where some of these Silicon Valley funds started intentionally looking outside of California for opportunities. Because they're like, oh my God, there are smart people elsewhere. And they, and in some ways, companies like ours weren't getting the same kind of attention as they were in Silicon Valley. So they probably got better deals going elsewhere. It was less of a picked over market. The Texas Medical Center right here started a venture fund, and they became one of our investors. And now we built a company within the Texas Medical Center, right? So the combination of capital and real estate became a really attractive thing for us. Coming back to your center of excellence ideas, because there's space here, I can now draw capital from elsewhere. We even went overseas, London, a group called Remind, East Coast, West Coast, and then here in Texas. So I think right now barriers are coming down, which means that you can source capital globally. And so then I think the question is, well, now it gives freedom to site your company in more places. And we picked here because of my clinical co-founder, Samir Sheth at Baylor College of Medicine, and all of the medical facilities here gave me amazing access to an incredible number of patients and really research active psychiatrists. So in some ways it decouples the idea of where's capital coming from and where's the best place for me to put my company in the world.
Yeah, and I think that ecosystem of the connection to health and great people feeds on itself. Yeah. And I think that's why the value of early stage capital from a local environment essentially has a multiplier effect for the companies that are located in that ecosystem.
Absolutely.
Can I add something to what Jacob said? I think that one of the unique things about biotech in general, including neuroscience investing, is that the R&D is largely funded by private philanthropy and the government. And so I don't know if you got any, you can raise money from investors at the same time you're getting grants. I know you're on the board of a company that raised capital and got DARPA grant at the same time. And so these private philanthropy and government grants, they don't ask for anything in return. So investors want a return of capital and a profit. They call it non-dilutive financing. That's very unique in this industry, and it's exciting because. But it's, like, I'm going to just use an oil example because we're in Houston, but horizontal drilling was one of the great innovations, for energy production. Unless you just hate fossil fuels, maybe it was bad. But it created a whole new, but that wasn't funded by the government. Oh, the government didn't invent fracking. It was the industry. So they paid for the R&D to create that. So we get to take advantage of great creativity being done and funded by grants. And that you can use that to create companies that can get it out to people, right? So, Jacob, your device, it's very compelling. I think it's going to, the modality works. It's just your interface. And, if it just stays in a lab for the next 10 years, what good is it? Because we know that TMS helps with depression. And you have a better mousetrap that you're working on. So we got to get it out. That's another thing about investing is that if stuff, the classic case of you do the research and then you go on to the next research project, or they call it the valley of death, where there's a gap in funders between grants and then venture capital because there's this gap period where it's still too risky for venture, but it's too late for grants.
Yeah, it's the number.
We're going to take some questions, so please do challenge us. It'd be great to have an interesting discussion about things we said, and I'm going to leave the closing comment of this part of the session to Amy.
No, I was just going to say it's one of the reasons that I'm in venture, right? I spent a lot of time in government and research and everything else creating and funding the things you're talking about. And I realized the most important thing I could do if I wanted to create a vibrant neurotechnology industry was to help commercialize it. That was literally the most useful, at least internally for me, the most useful thing that I could do to help create that, and of course, be part of these larger conversations. And I think that's the commercialization. There's nothing, it's not every researcher like Jacob that can turn into a CEO, but there's a lot of intellectual property and scientific insights that can be operationalized and commercialized. So.
I do. I'm sorry, I'm going to jump in here, even though he made us so close, because I think it's so important. And it's very personal to me. This company that I believe has an opportunity to make a huge impact on people's lives exists because we had non-dilutive funding. We were a part of an $18 million DARPA program that allowed me to get the technology de-risked. I even got first-in-human data before I started my company. It was only because I had that data that my company was investable. It would not exist here today had I not had that non-dilutive funding. And then when I went out and I founded the company, I had to communicate, to the investors, they're taking this huge risk, but I have a track record of being able to attract more non-dilutive funding, and they were able to take that risk because of the belief that their dollars were going to get supplemented by non-dilutive funding. And I think that evaporates and makes it so much harder for companies like mine to do something that's truly innovative.
Yes. I'd like to close by coming back to the question about non-dilutive funding from the US, which I think it's fair to say the world has been an enormous beneficiary of that non-dilutive funding for research within the US. And I think one of the answers is that in the interim, the US may need to move to a leadership model rather than a do all the investment model. And what I mean by that is that I think the opportunity to lead scientifically, use the capital that is available to start up, to create an ecosystem and a multiplier effect, I think will inspire other countries around the world to actually start picking up some of the non-dilutive funding and even the returns-based funding. And I would say, having spent 3 years with Harris Air in the brain capital movement, one of the most powerful things about that is that it's global, but it needs leadership. And I think that is where I would leave the thought for the day, which is that the opportunity is presenting itself for that leadership. And I'd love to be part of Houston taking the baton on that and bringing it together for the benefit of really all people suffering from brain health issues and productivity. So I'd like you to join me in thanking
Thank you all.
Thank you.
my panelists for a fascinating discussion. Thank you.